notation, what you're doing is you're taking a sequence and adding it or subtracting it together. So then it's called a series. And the sigma notation is just means sum. So it's because you're adding them together. So that's why they use that notation. So we want to learn how to use the notation. The mathematics likes to use a lot of notation so that we can shorten things up and not write as much. Which I'm all for that, because it would be a lot more writing if we didn't do that. But if you don't keep up with your math, it can get a little difficult to understand and read it. Okay, so let's see where we're at here. I know we're doing W.10 is the Sigma Notation site in IXL. That's your assignment there. Okay, so intro to Sigma Notation. Understand basic Sigma notation, interpret Sigma notation to find the sum of a series, and to write the series using Sigma notation. That's your objective. There's a really short, really good video there about Sigma notation. And then a discussion about what do you use Sigma notation for, or sequences or series, what are they used for? Cool Math article, if you go ahead and look at the Cool Math article, there's a little quiz at the bottom. If you go through the quiz, then you can mark it as done and just mark a 100. So this is called Sigma, and it means sum in a different language. So we're looking at a different language. That's why it's pronounced like that. So whatever is after sigma is what we're adding together. They'll give you an index here and here. They're called the lower limit and the upper limit, that tells you from which term, the sequence to which term you're going to add them together. For example, n equals 1 to 4, and your rule here is just n. So you put 1 in for n, plus put 2 in, 3, and 4, and then add them together. 2 plus 3 plus 3 plus 4 is 10. And then, of course, it gets a lot fancier. But this shows you which value to start with and which one to end with on the top and the bottom of the sigma symbol. So, of course, you can put anything here. N squared, starting with 1, would be 1 squared, plus 2 squared, plus 3 squared, ending with 4 squared. And then you add it all together. And 2n plus 1, there's a bunch of examples here. And then when you do the little quiz, there's a whole bunch of examples for you to work with. And so there we go. Sigma is S in Greek. And they make it like that. You've seen that a lot, a sigma, delta, whatever, for fraternities and sororities and stuff, I'm sure. Okay, so you have to do that, and then the other thing you have to do is a W.10. So I have a few notes for you to go over with me, because this is a little bit different compared to other notation that you've seen. Okay, so I have 3 examples for you, and go over the definitions a little bit more. So all you do is you make this squiggly thing. It's just like an E kind of line, and then you go in, out, back in. That's sigma. So sigma notation. Or kind of more in English, it's called summation. The summation, they might say the summation when you see that. So this is also summation notation. So definitions up here, the number you'll see up here is often called the upper limit. And the number down here is called the lower limit. And they are also an index. So they're also indices, which is the plural of index, the index number. Okay, so things about sigma notation. It can either be infinite, which I know it's hard to imagine adding together an infinite number of numbers, but we do it. Infinite would be your upper limit then, infinity symbol. Or finite, which is what we're going to work with more, but Excel does have some infinite series there for you to look at. Finite means that it does end. It ends at the upper limit, whatever number is up here. Of course, A sub n, your nth term. Hang on a second, let me make sure that person got in. I heard somebody enter here. Okay, that should get them in. Okay, so A sub n is the nth term. Or you can do other letters like x sub I. And of course, n is the term number. And A sub n also stands for the sequence rule. All right, and a series, because you're adding the sequence together, is called a series. A series is a sum of a sequence of numbers. So it's a lot easier to understand when you actually do a problem. So example 1, do the summation of 3n plus 5. We'll start with 1 and end with term 3. Okay, so you're going to put 1 in first. 3 times 1 plus 5. And then you're going to add. We're going to go up to 2. 3 times 2 plus 5 plus, last term we're doing is 3. So 3 times 3 plus 5. And then you add all of this together. So 3 times 1 is 3 plus 5 is 8. 3 times 2 is 6 plus 5 is 11. 3 times 3 is 9 plus 5 is 14. That'd be 1933. So the sum is 33. Kind of different, isn't it? Very interesting. Okay, another example. So example 2. Here is the series. 1 plus 4 plus 7 plus 10 plus 13 plus, we don't know, whatever's in there, plus the last term is 19. Okay, so you're supposed to find the summation, starting with 0, going to, we don't know what, for whatever sequence we have here. So you need to find the sequence rule, and also what is the last term, the n for the last term, n equals what? Right, so as you can see here, each time you're adding 3. So this is the problem where you have a common difference. And since n equals 0, this will be n equals 0. This would be where n is 1, n is 2, n is 3, n is 4, and here we're not sure. N is question, and that goes here when we figure it out. So you have a common difference. each time of 3. If you graph a sequence like this, its points would make a straight line. So that 3, we use 3 and plus or minus some number. It's definitely not just 3. 7 times 3, I mean, it's not going to get you to the next number. So let's look at an example where n equals 3, we get 10, right? So 10 equals 3n, so 3 times 3 is 9 plus 1. So it looks like it's going to be plus 1. We can try another one. You can do where n equals 4 is 13. So 3 times n, that's 4. 3 times 12 plus 1. So yes, the rule is 3n plus 1. Okay, so we have the rule. We just need our upper limit. So far, we have from 0 to question mark, we're 3n plus 1. You can put parentheses around that if you want to. Okay, so to figure out what goes up here, we know that we get 19 as the answer, so let's just do what we were doing before. 19 equals 3n plus 1. So subtract 1, that gives you 18 equals 3n. And divide by 3. 18 divided by 3 is 6 equals n. So your final entry is for n equals 6. That's your upper limit. Okay. Any questions so far? All right, let's do another example. And like I said, you don't have to use n and a and n. You can use other letters like x sub I instead of a sub n. Okay, so we're going to write the series with sigma notation. So example 3, your lower limit is 0. Okay, so far all we have is 0 here. Have to find the upper limit and the sequence rule. So here is what your sequence is. -4, minus 20, minus 100, minus 50. So you know when you're subtracting, it's the same as adding the opposite, so it's still a summation. So they want us to start with 0. So this would be where n is 0, n is 1, n is 2, and n is 3. So we can fill this in. We're just adding the first 4 terms, 0, 1, 2, 3. Okay, so if you look at this series, the initial value here is -4. And I'm interested in the initial value because, as you can see, you're multiplying here. You're not adding. It's not a common difference problem. Each time you're multiplying by 5. You have a sub 0 equals your initial value times 5 to the 0 power would be -4. Anything to the 0 power is 1. So that does equal -4. So let's see if that works for n equals 1. And -4, the initial value, and your base is 5 raised to the power of n, so that's 1. That's -4. 5 raised to the power of 1 is 5. -4 times 5 is -20. And a sub 2, we have the initial value, 5 to the power of n, which is 2. -4 times 25 100. So it looks like we're on the right track here. And for n equals 3, we have our initial value. Take 5 raised to the power of n, which is 3. Negative 4 times 5 cubed. 5 times 5 is 25, times 5 is 125. Negative 4 times 125 is actually negative 500. So we get all those values. Now we just have to add them together. So let's see. Negative 4 and negative 20, that'd be negative 24. Plus negative 100 would be negative 124. And negative 500 more. Negative 624. So your summation here is negative 624. So what is our rule? It's negative 4 times 5 to the power of n. Or whatever letter you use here. If it's I, you would put I here. Equals negative 624. Okay. So that's your answer. And we also found the sum. It said write the series using Sigma notation, but we also found this sum. We did the summation problem too. All right, so like I said, what you have to do is in IXL is W10. So let's go to the IXL site. Sometimes this closes when I open IXL, so if it does, just hold on and I'll rejoin. As it closes, sometimes it doesn't. It's fickle. Do either of you want to share your screen instead of me? We can help you with your IXL that way. Okay, number there. Okay, so we're going to W10. Introduction to Sigma notation. All right, so classify the series. It goes from -1. I don't know if you can see this because my screen is so small. Or from +1, 1 to 100. Okay, so that's ending. If it's infinite, you'll see an infinity symbol, so that's finite. How many terms are there? You have 1 to 100, so that would be exactly 100 terms in this series. Okay, classify this. That's finite. How many terms? That's 86, I think. Very tiny. Oh, it said 88. I couldn't see it. Okay, this is 42. I can see that one. Okay, finite goes from 1 to 70, so there are 70 terms. This is finite, goes from 0 to 78, so there are 79 terms, including 0. It would be 1 to 78 would be 78 plus 0 is 79. Okay, this is finite. 0 to 15, there would be 16 terms. Finite. From 1 to, I think that's an 18, that would be 18 terms. Okay, so here it says from 0 to infinity. That's an infinite series. And this is 9 to 50, so that's finite. And let's see, 50 minus 9 would be 41, but counting the 9, that would be 42. This is infinite. 9 to 26 is finite. How many terms? Let's see. 9 would be 17, so that'd be 18, including the 9. We found the difference, but you want to include the beginning 9 and the ending 26, so it's actually 18. Write the series using sigma notation with a lower limit n equals 0. So they all say n equals 0, so you can't get rid of any of these as distractors. You can add 10 and 40 is 50. And these two add up to 800. So 850. I don't think that matters. 1, 2, 3, 4. 0 to 3. Okay, all of those are 0 to 3. Beginning value, initial value is 10, 10. Okay, that one's out. Okay, are you taking 10 times 1/4 to the n minus 1? Or 10 times negative 4 to the n? Or 10 times 4 to the n? Let's see, you're starting with 0, so when you put 0 in here, you would not get 10. Okay, so it's between these two. The 0 in here is 1 times 10 is 10. 0 in here, 1 times 10 is 10, so it's one of these two. Okay, when you put 1 in here, 10 times 4 is 40. Put 1 in here, you would get 10 times negative 4 is negative 40, so it has to be this one. Okay, so I'm already at 72, so you can definitely pass this one. Here your lower limit is 1. You have 1, 2, 3, 4, 5, 6 terms. This one is out because it says 8, that one says 8, so it's between these two. So just test it. When n is 1, 7 times 1 is 7, plus 4 is 11. Here when n is 1, 7 times 1 is 7, plus 5 is 12, so it has to be this one. Okay, so that's how you do them. All right, that's what I have. Do you have any questions? I'm trying not to give you too much work because it's almost, we have only like this week, next week, and then we have the review and finals in the next week. That's it. So we only have one more week other than the finals week.
Can you repeat almost everything you just said? Because for some reason it disconnected me.
Did you see the notes? Which
Yeah, I saw the notes. Like once you finished the notes, it just disconnected me.
Okay, do you know how to share your screen? Do you think you can, I'll make you a presenter, do you think you can share your iExcel screen? Open your iExcel and go to W10, and then you press this little share thing right here. And there's a screen over here. You have to click on that, and when it pops up, you click on it and press share, and then it should share, and I should be able to see your iExcel. How are we doing?
Which one do you tell me to get on?
Go to iExcel W as in waterfall 10. Okay, I can see it now. All right, it says classify the series. Since it goes from 1 to 68, that's finite ending. So press finite. You can go ahead and click finite. Are you frozen? Okay, and then it says how many terms are in the series. So it goes from 1 to 68, so that's 68 terms. So in that blank, you just put 68. Okay, this one's really similar. It's finite. If it's infinite, it has an infinity symbol up there. You'll know it when you see it. So this is finite and goes from 1 to 96. So it has 96 terms, right? Okay. Also finite. But see how it goes from 0 to 78? So it actually has 79 terms, including 0. Because it didn't start with 1, so it has an extra term. So it's 79 terms. Yeah, so you just type 79. I think your computer's frozen again. You understand why it's 79 instead of 78? It's because it starts at 0. Oh, you're ahead of me. Okay. Yeah, that's right. 28. Good. Okay, see how it has an infinity symbol up there? This one is infinite. Yeah. Same thing. They make more. That's easy. Okay, these are the ones that are more difficult. It has a lower limit of 1. So as you can see, all of these have a lower limit of 1. So you can't cross any of them off as a distractor. All right, so when you put 1 in there, you're supposed to get 1. So the first one would work. 2 times 1 is 2 minus 1 gives you 1. The second one, 6 times 1 is 6, minus 6 is 0. So the second one is out. And the third one, 6 times 1, and then you get 6 minus 5 is 1. So it could be the third one. And then the fourth one, you have 1 plus 6 is 7. So it's not the fourth one. So it's between the first one and the third one. So try the next term. Plug 2 in. And the first one doesn't work because 2 times 2 is 4, minus 1 is 3. So go to the third one. When you put 2 in there, 6 times 2 is 12, minus 5 is 7. So it has to be that one. Yeah, the third one. To get 7 when you put 2 in there.
Why did you use 2?
Well, the n equals 1 means the first term. And here, you put the 1 in and you're supposed to get 1. When you go to the second term, you're supposed to get 7. So when you put 2 in there, you're supposed to get 7. So in the third one, 6 times 2 is 12, minus 5 is 7. So that's the correct rule. And then when you put 3 in, you're supposed to get 13 and so on. So you have to pick the one that actually works. Okay, here your lower limit is 0, so it says n equals 0. Notice that your top number there, some of them say 5 and some of them say 6. There are 1, 2, 3, 4, 5, 6, 7 terms. So it goes from 0. The first term is n equals 0, n equals 1, 2, 3, 4, 5, 6. So the top number, the upper limit should be 6. So it's between 1 and 2, the first and second one. Okay, so just put 0 in there and see if you get 5. Because the first answer is 5, right? So when you put 0 in there, you're supposed to get 5. When you put 1 into the rule, you're supposed to get 8. So that first one doesn't work. The second one works. Here you have a lower limit of 1. They all say 1 at the bottom, so that's not a help. They all go up to 5, so that does not eliminate any. Okay, so you're going to have to try the rule. So when you put 1 in the first one, you do get 3. So it could be the first one. In the second one, you put 1 in there, you get 3 as well. Here when you put 1, minus 2 is negative 1, and you get like 15, so it's not the third one. On the fourth one, when you put 1 in there, you also get 3. Okay, so the only one we could eliminate was the third. So move on to the next term, which is where n equals 2. Okay, in the first one, if you put 2 in there, 3 squared is 9, so it's not the first one. On the second one, if you put 2 in there, 2 minus 1 is 1, you get negative 5 times 3. That's negative 15, so it's not that one. So hopefully it's the last one. When you put 2 in the last one, oh, you got it? Okay. So you understand how to do them? Or are you still lost?
No, I don't understand.
Okay, so it goes to figure out if it actually does produce those terms that you see. So it starts with n equals 1. So when you put 1 in there, do you get 7? So the third one doesn't work because when you put 1 in there, you get negative 7. Right? So that one's no good. So it's between the first one, the second one, and the fourth one. So plug 2 in and see if you get 28. And the first one you do. And the second one you do not. You get 35. And the third one did not work. So 2 and 3 are out. And then the fourth one, when you put 2 in there, you actually get 7 squared is 49. So the last one doesn't work either. So it has to be the first one.